The figure below shows 3 triangles drawn between parallel lines. How do the areas of the triangles compare to each other? First, we should know which triangles we're even talking about. There's a triangle ABC. Let me outline triangle ABC. ABC. There's that triangle. There's a triangle ABD. I really should use a different color. ABD is that triangle. And there's a triangle ABE. That would be this triangle. Well, they've given us no dimensions, so how are we going to calculate area? We could at least write the formula for area. Area is 1/2 base times height for each of these. They're all triangles. Well, the base is this distance for all 3 of them. That's the same. What about the height? The height for ABC is the perpendicular distance right here, this distance. The height for ABD is this perpendicular distance. Oh, that's the same as this. And the height for ABE is this perpendicular distance. Because these lines are parallel, all 3 of those heights are the same. And AB, the length of line segment AB, is the base for all 3 triangles. If they have the same base and the same height, then they all have congruent areas. They're all the same. All congruent. Let me erase all this writing and let me see if we think that seems reasonable. That these would all take up the same amount of 2-dimensional space. ABC, that vertex is way off to the left. So it's kind of like, you kind of have to think about it this way when you're trying to think of if it seems reasonable. This piece of ABC that's outside of ABD would have to be equal to this amount of 2-dimensional space. Does it seem reasonable that this amount of space is equal to this amount of space? I think it does. And so that's one way to kind of convince yourself that this is true.